So this is chapter 8. In this chapter, we're going to talk about exponential and logarithmic functions. So the first half of this chapter, it's going to be concerned with exponential functions. And the second half of the chapter will be concerned with the logarithmic functions. Okay with that idea? I mean, you don't know what these two things are yet, but I'm just trying to give you some framing for what we're planning on doing, right? Sometimes that's helpful in making sure you're kind of following along, that you know what the plan is and how we're going to move through the chapter. So let's start by just defining what we mean by an exponential function. Oops. I should say where B is all right. So we're going to say that an exponential function is of the form y equals a times b to the x minus h plus k, where a is non-zero. Why is that important? What would happen if a was 0? You just have the k left, right? And k is not a variable, so this would not be, there'd just be a linear function, which is not interesting. Okay? And we say that b has to be positive and not equal to 1. Right? That's what that second part is saying. Why does b need to be positive? Well, keep in mind that x here, the exponent, has a variable in it. So the exponent could be things like a half or a fourth or a third, right? Everybody's okay with that? And remember that a fractional exponent is the same as a radical, right? Specifically, let's say the exponent of 1/2 is the same as which radical? The square root. And can we square root negatives? No. Okay, those aren't defined over the real number, so that's a why, or one reason why anyways, we're restricting the value to b, for b to have to be positive. Everybody's okay with that idea? Also, we are saying that b can't be equal to 1. Why can't b be equal to 1? What would happen there if b was 1? b to any power is, or I'm sorry, 1 to any power is 1. So this would just turn into a plus k, right? Which aren't variables. So that's just a linear function again, and we don't want that, right? So that's the reason why. Everybody's okay with the restrictions we're placing there and why we're putting those restrictions? Okay, that's good. So, oops. So we're going to call b the base of the exponential. And there's two types of exponential functions. The first kind is called exponential growth. That occurs when b is greater than 1. And the second kind is exponential decay. That occurs when b is between 0 and 1. Okay, so let's look at a couple of examples here. I'm going to write an exponential function, and I'd like you to help me determine whether these are, or the function is growth or decay. Good. So what's the value for b in this case? 5. And since 5 is greater than 1, this is growth. Everybody okay with that idea? Tom?
Are we going to eventually have to solve for that x plus 1, or like what will we end up doing?
So, like we've done for most of these different function types we've talked about, the three skills that we'll be working with is we'll talk about graphing the function, like simplifying it, like how does it combine together, and then solving. So we'll talk about all of those different things along the way. Okay? But right now we're just kind of in the very beginning phase of like getting used to what the function looks like. How about this one? What's the value for b here? 10 over 3. Is that bigger than 1? Yes, so it is growth. How about this one? What's the value for b here? It's just 0.01, right? So is this growth or decay? This is decay. Do we feel comfortable picking out which one is which just by looking at the function? Good. So to graph an exponential function, the way that we're going to choose our values for x are going to be in this fashion. So I'm going to pick my values for x as h minus 2, h minus 1, h plus 1, and h plus 2. So I'll do it that way kind of every single time. So this is kind of like our little formula. Is somewhat similar to when we graphed exponential functions, right? Or not the radical functions last chapter, right? Where we use those h's and k's to kind of determine what values of x and y we were using. Okay. God bless you. Let's say that we want to graph the function y equals 2 to the x plus 1 equals negative 5. So the first thing I'm going to do is list my values for a, b, h, and k. So who knows one of those four? Can somebody tell me one of those four? K is negative 5. That's good. Thanks, Hannah. Can someone else tell me one of them? B is 2. Thank you, Jack. What? A isn't 0. It's 1. Remember, A is being multiplied. If there's a multiplication constant that's not there, it's 1. And then last one, who can say the H, Dan? Close. Negative 1. So remember, the H's are always the opposite sign of whatever they appear in the formula. Does everybody feel okay there? Just as a quick aside, is this problem growth or decay? This is growth, right? Okay. So I'll fill in my values for x according to my table. Everybody okay with what I did there? So I did h minus 2, h minus 1, h plus 1, and h plus 2. How do you suppose I'm going to find these y values now? I'm just going to plug them into my calculator, right? So 2 to the negative 3 plus 1, and then minus 5. So my first y coordinate's negative 4.75. And then negative 4.5. What did I do here, guys? I don't know. I didn't do, never mind. That first one thing is wrong. Great googly moogly. There's my first one. There's my second one. There's my third one. Better stop and write some of that down before it goes off the screen on me. Oh my gosh. Ugh, everybody stop. Your teacher's being stupid. Okay. Sorry. Hey, look, guys, I'm sorry. Look. All right, so what am I trying to do here? I'm plugging these x's into this equation, right? So I was doing it right the very first time. Goodness gracious. And I don't know what happened. We had 2 days off and it's after lunch and my brain is just feeling foggy. You know? All right, so that's the first three of them. You ever make a mistake? Happened to me. Okay. So let's plot our points. So I have -3 and -4.75. This may be there. -3 and -2 and -4.5 is maybe there. -1 and -4 is maybe there. 0 and -3 is there. And then 1 and -1 is right there. Is everybody okay with the points that I've plotted? One interesting feature of these graphs for exponential functions is that every graph of an exponential function has a horizontal asymptote. Do you remember when we talked about asymptotes at the very beginning of the first semester when we talked about domains and ranges? That's okay. We'll talk about it again. So this particular function has a horizontal asymptote at y equals -5. Well, they're always going to be at y equals k. And what these asymptotes are, it's kind of like an imaginary line that the graph will approach but never cross. So it can get really close to it but can't jump to the other side of it. Everybody's okay with that idea? So which end of my graph appears to be approaching the asymptote? The right end or the left end? It's like down here, it's getting really close, right? You guys agree with that? So the left end, we're approaching the asymptote. So I'm going to, when I draw my graph, I'm going to draw the left end of my graph, just kind of following my asymptote. And then I'll go through those points. And draw my arrow at each end. Is everybody okay there with how I drew that? Okay. What do you think the domain is going to be for this graph? Which coordinate is the domain talking about, the x or the y? The x. So it's going to go, you notice we have an arrow pointing to the left, correct? So that's going to go all the way to negative infinity. And I also have an arrow pointing to the right. So it'll go to positive infinity because it's connected in between those two arrows, right? Everybody's okay with that idea? So the nice part for exponential functions, the domain is always going to be negative infinity to positive infinity. That's good, right? What's the range going to be? Do I have an arrow pointing down? No. Okay. So what's the smallest value that my graph appears to get to? -5, right? Now, is the graph actually getting to -5? No. Remember, we have this asymptote that it can't cross. So instead of putting a bracket at -5, I'm going to put a parenthesis there. Do I have an arrow pointing up? Yes, right? The right arrow is pointing up. So that tells me we're going all the way to positive infinity. And since those two arrows are connected in between, I know it goes in between. Everybody's okay with that idea? So in general here, if the a value is positive, we'll go from k to positive infinity. And if that a value is negative, we'll go from negative infinity up to k. So this is like the general statements for these. Yep, just depending on whether the coefficient there, the a, is positive or negative. Correct. The k values always has a parenthesis rather than a bracket, because the asymptote is where that k value is, and the graph can't actually have a value there because it can't get to it and cross it, right? Can't even touch it. Hi, Lexi. Thanks, my dude.
No problem.
Tommy, you got to get out of jail free card here. before the end of the 8th hour. It's not bad. Doesn't help you out of this class, but oh, that's so nice. All right, why don't you guys take a few minutes here and try to find 5 points and graph y equals 3 to the x minus 2 plus 1. We'll give you guys, 5 or 6 minutes to kind of work on that. We'll go through it together here in a minute. So if you get stuck, don't fret none. Look back at the previous example a little bit. Give that a shot. Do the best you can, and we'll go through it slowly together in a minute. Sound good? Okay. Yes, sir. Of course. Yes. Very good. Of course. Okay, so here's our XY table and our graph. What do you guys think? Is this what you guys got? Close-ish? Did I go too fast? Did I not give you long enough to pick away at it? Work faster! Yes, sir. Certainly. Okay, so we've seen exponential growth, and we've seen that in both of these two examples, right? What do you suppose the graph of exponential decay is going to look like? It's going to be kind of like it's reflected across the y-axis. So the left end is going to be pointing up, and the right end of the graph will be like flat. So let's look at an example of that. So let's say we have this one. What's my value for A going to be? 2. Good. My value for B? 0.25. My value for H? 3. And my value for K is 1. Everybody good with that? So notice that this is decidedly decay, right? So my values for x should be 1, 2, 3, 4, 5. If you don't trust me, you can work that out on your own, but you can take my word for it. I hope you trust me. Most of the time, anyways. I do make mistakes, but it wasn't It wasn't this time. I'm on it now. That's a 9, by the way. I don't know if that was clear or not. Everybody okay there? All right. Uh-oh. Well, that's all right. We'll just make it work. There's my asymptote. Then I have 133. I don't know. That's going to be like up there somewhere. 2 and 9. 3 and 3. 4 and 1.5. And then 5 and 1.25. So there's my graph. Again, notice that the left end of my graph is pointing up and the right end of my graph is kind of laying flat along the asymptote. You guys notice that? The domain for every exponential function is going to be all real numbers. And the range for this one is going to be k to positive infinity, since the leading coefficient was positive. Is everybody okay there? What do you guys feel about graphing these guys? Hopefully that's not so bad, right? We're going to stop here because I don't want to bite off too much.